Hi guys, welcome back. It is Saxon 8-7, lesson 2. Oh, I gotta do something about my hair. It's such a hot day. Ugh, a little sticky. Okay, it's for my 7th graders, it's our 2nd lesson together. Today we're gonna talk about fact families and we're gonna talk about some rules of addition and multiplication, okay? First things first, a fact family. So families are addition, subtraction, and multiplication and division, okay? Addition, subtraction, multiplication, and division. Let's talk about addition and subtraction first. 7 plus 10 equals, actually let's do 7 plus 3 equals 10. Now you probably know that 3 plus 7 equals 10. 7 plus 3 equals 10, 10 plus 7, or 3 plus 7 equals 10. It's the sunshine, it's going to my head. Okay, we can always flip these guys around. And guys, if you don't have your notebook out, now is a good time to get it because I'm gonna be giving you a ton of terms, okay? The fact that we can flip our addition problems around, that's called the any gosh darn order property. It's not really called that, but that's what I call it. Commutative. Commutative. I want you to write that down. Commutative property. Maybe we should write that. Property. The any. Oh man, with my math today. My English. I don't even know. Any gosh darn order. We can write that in any gosh darn order. You know, the same thing is the case for 7 times 10. That equals 70, right? 10 times 7 equals 70. Look at that. It works for addition and multiplication. Now, going back to those fact families, here are our addition facts, right? 7 plus 3 is 10 and 3 plus 7 is 10. Here's the deal with your addition facts. If you add in this direction, you can subtract in this direction. And what I mean by that is we can do 10 minus 3 equals 7. 10 minus 3 equals 7. If we add in this direction for this guy, we can subtract in the direction for this guy. That means 10 minus 7 equals 3. Guys, there are 4 facts in your addition and subtraction fact families. We can flop those addition ones around, and then we can get our subtraction facts from there, okay? This works the same for multiplication. Let's do 7 times 3 equals 21. Well, we also know that 3 times 7 equals 21. 7 times 3 and 3 times 7 equal 21. If we multiply in this direction, we can divide in this direction. So 21 divided by 3 equals 7. You see that? If we multiply in this direction, we can divide in this direction, which means 21 divided by 7 is 3. There are your multiplication and division facts right there. So that's kind of an easier way to see that. Now, that order, that any gosh darn order, we can also do, there's going to be a couple of other terms that I want to make sure we get to. The identity properties. Identity, we need to talk about those, okay? Identity. Oh my gosh, I just had to sound that out in my head. Identity property, goodness. Property of addition. It looks like this. 17 plus 0 equals 17. 3 plus 0 equals 3. 1, 2, 3, 4 plus 0 equals 1, 2, 3, 4. I think you're catching on to this one, right? The identity property says we're allowed to add 0 to anything. It's going to be the same thing, right? We can just slap a 0 on the outside. This seems really dumb to say this out loud because it's like, well, duh, that totally makes sense, right? But the reason that that's popular is because when we get into some algebra, we often have to use 0 as a placeholder for some of those things. So it's really good to know that. Now, the identity property of multiplication doesn't use 0. Multiplication doesn't use 0, because if we did 17 times 0, we'd get 0. 3 times 0, we'd get 0. So that doesn't work. The identity property of multiplication is 17 times 1 equals 17. 3 times 1 equals 3. 1, 2, 3, 4 times 1 equals 1, 2, 3, 4. We're allowed to multiply anything by 1, and we get that same thing, right? This is really helpful when we're dealing with fractions, guys. You're allowed to multiply by 1. That's a big one. Those are your identity properties, okay? Of addition and of multiplication. Okay, so they may be called something different in the book, like additive identity. Oh no, thus the 0 is the additive identity. But that's basically the idea here, okay? One more property that I want you to be aware of is called the associative property. The associative property. Now, when you think of an associative property, when you think of an association, right, you think a grouping, like the association of book readers. That's going to be a group of people who read books. It's the same idea for multiplication and division. If I have this 1 plus 2 plus 3, and I put these guys here, and I say 1 plus 2 plus 3, we can put this here, right? Now, you'll maybe learn a little bit later, so that we always do things in parentheses first. So in this case, 1 plus 2 is 3, plus 3 is 6. Here, 2 plus 3 is 5, plus 1 more is 6. That means that we can do these in any order. What I call, or not in any order, it means that we can do them with the parentheses can be grouped together. I call it the grouping property. We call this the grouping, right? So you may want to write that down, grouping. You'll see this come up a few times. It's not as popular as the commutative property, but now the same thing for multiplication. 1 times 2 times 3, 1 times 2 times 3. This times this is 2, times 3 is 6. This times this is 6, times 1 is 6. So 6 equals 6. It's just we're grouping those things a little bit differently, okay? All right. So with all of that said, the next thing that we're going to do, is example 1 on page 9. And guys, I'm following along in the Saxon 8.7 second edition book, second edition. On page 9, example number 1, it says name each property illustrated. Okay, go through those. If you have any questions, let me know. Let's see. A sequence. Sequences. So the definition that's written here, a sequence is an ordered list of numbers that follow a certain pattern or rule. A list of the whole numbers is an example of the sequence. So in this case, they're just listing out 0, 1, 2, 3, 4. Previous lesson, you heard me do that, or you saw me do this for whole numbers and counting numbers, natural numbers, all that good stuff. But sometimes sequences can have gaps, okay? For example, on example number 3. Example 3. What we have is 1, 4, 9, 16, and then ... And it says to find the next 3 numbers in this sequence. Well, what we want to do is look, what's the difference? And difference, remember, means subtraction. What's the difference between 4 and 1? Well, it looks like if we add 5, maybe? Nope, doesn't look like that. Let's look at this guy. 1 to 4. Nope, it looks like that's 3. That gives us that, right? 4 plus 5 gives us 9, right? 9 plus 7, because I'm just subtracting these guys, gives us 16. What do we think is going to happen next for the next 3? Well, 3, 5, and 7 are all odd numbers. So perhaps after 7, we're going to do plus 9. And that's going to be here. And then plus 11. And then I'm all the way off the board here, plus 13 right here, right? So we take a look at that, and if we add 9 to here, we get 25. If we add 11 to that, we get 36. And if we add 13 to that, we get 49. You see that? So those would be the next 3 in the sequence. So when you're looking at sequences, ask yourself, what do I need to add or subtract to get the next number? That's going to be the most helpful. All right. So take a look at that. If you have any questions, let me know. Give those practice problems a shot. And then if you have any questions, we'll talk about them in class. Thanks, guys.